So finally, the time has come to learn, how is an atom actually built? If there's 118 atoms in the universe and, 92 or 90 that exist naturally on Earth, how do we know all about them? The answer is the periodic table of elements. Here he is right here. He's going to be your new BFF for the next couple of weeks. So, learn to fall in love because he's glorious. Tells us all about all the atoms in the universe. And every different atom has a different square. So each square tells us about each individual atom and how to build it with protons, neutrons, and electrons. So if we look at the first square here we're going to talk about today, let's talk about beryllium. There are always 4 things on a periodic table in any kind of square. Some have more, but most of the time you'll see these 4. We have an atomic number that's always a whole number, an atomic symbol, and which is one capital letter, always at least one. And then sometimes you're going to see a lowercase letter, and we're going to look at kind of that in a second and why they're different. And then we always have an element name. It's nice. And finally, we have an atomic mass. And that atomic mass often is going to have a decimal place, whereas the atomic number will not. The atomic number tells us the number of protons, because that's its identity. And then the atomic mass is the number of protons and neutrons added together, which can differ sometimes in some different atoms, and that's why there's that decimal. That's going to be some high school chemistry stuff. For our purposes here, we're learning basics. So let's talk about atomic symbols for a second, because they're not there to confuse you. They're actually there to make life easier. The thing with elements is that their names are way too long to write out all the time, because there are some things that have like 7, 8, 10, 12 different atoms stuck together. So the symbols are like initials, and they make it a lot easier for scientists to write about elements. Now, sometimes they're just going to have one letter, like H for hydrogen. That's happy. That one's easy. And that's okay, but it's got to be a capital. Sometimes they're going to have a capital and a lowercase. It has to be capital, lowercase, not 2 capitals. But the capital and lowercase, it's not always in the same order. So chromium, CHROMIUM, is CR. Sometimes the letters don't seem to have anything to do with the word at all, and it's because a lot of the names were invented before English was. So gold is AU for aurum because that's its Latin name. And then down at like the bottom of the table in the 1 teens, we have these 3-letter ones, and those are 3-letter placeholders given to atoms that have not been discovered yet. So this one is un quadium, and that's the Latin name basically for 114. So that's why some of them are going to have, 3. But whatever it is, you just got to write it like it is, and the capital and lowercase is very important. The next thing we need to hash out is atomic mass versus atomic number. Atomic number is always the number of protons, and the atomic mass is how heavy the atom is, how many things are sitting on the couch. So if we look at boron, it has an atomic number of 5 and an atomic number of 10.811. We're going to round that up to 11. If it was 10.1, we would round it down. So the atomic number tells us we have 5 protons. The atomic mass, we still have 5 protons, but what we need to do is subtract the atomic number to find out how many neutrons, which is 6. So 5 plus 6 equals 11. That's our atomic mass. That's how many big fat protons and neutrons are sitting on the nuclear couch. Okay? Atomic number, protons, is the identity. Atomic mass tells us how many big guys are sitting on the couch. Okay, next one. Let's look at gold. Gold has an atomic number of 79 and an atomic mass of 196.97. We're going to round that up to 197. It's so much nicer to talk about whole numbers. That's gold. Okay, so gold has 97 protons. 79 protons, sorry. And then we need to subtract that to find out how many neutrons. 118. So we have 118 neutrons, 79 protons, which gives us a grand total of 197 big things sitting on the couch. Mass, how many big things are on the couch? Number, the identity with protons. Got it? Yes? Good. So we're going to slow it down a little bit into a little bit of real time because we need to learn how to build an atom. So if we look at one square of the periodic table, which is all we can look at when we're building an atom at a time, let's take hydrogen. Hydrogen has an atomic number of 1, which means it has 1 proton. It also then is going to have a mass of 1 proton, And if we do that subtraction that I was telling you about with the mass, then 1 minus 0 is 1. So we don't add any neutrons. That's it. That's the whole nucleus. Now, there has to be as many positives as negatives because the atom is neutral. So we're going to put 1 negative out there. And voila, here's a completed hydrogen atom. Atomic number of 1 tells us 1 positive, 1 negative. And the atomic mass is 1, which is our 1 proton. Ta-da! Super easy, right? Let's do something a little bit bigger. Let's talk about all the way on the other side of the periodic table. We'll talk about why that exists that way in a little bit. We have atomic number 2, helium. And we have 2 protons. Because atomic number 2, 2 protons, that's what that means. Then because we have 2 things in the nucleus, we need to figure out how much else. So 2 protons, 4 minus 2 is 2, which means that we have 2 neutrons. So now we have a nucleus that has 4 particles. Nucleus done. Hooray! It has 4 things in it. 2 protons, 2 neutrons. Now, atoms are always neutral, so the protons have to equal the electrons. Positives equal negatives. So there's going to be 2 negatives floating around in the electron cloud. And there we go. Hip hooray, we have a helium atom. 2 protons, 2 neutrons, 2 electrons. Okay, so those are the 2 easiest ones to build. They're the smallest, they're also super abundant. Let's get into something a little more complicated. So now we have lithium. 3 and 6.941 is the atomic mass. Now we're always going to round the atomic mass up to a whole number. So we're going to round 6.9 to 7 because you have $6.94, you almost have $7. We have 3 positive protons, so we're going to put those in our nucleus. And then because they're in the nucleus, right, we're going to account that we have 3 in that mass. So the nucleus is the atomic mass because it's the fatties on the couch. So we have 3 positive protons, and we need to figure out how many neutrons. We're going to do 4 neutrons because 3 plus 4 equals 7. And now we have a nucleus with 7 particles and 3 positive protons. Mass equals 7, right? Neutrons separate the protons. That's why they're there. So as the atom gets bigger, we typically are going to have more neutrons than protons because we have to separate out more and more protons because it's a 3-dimensional deal. Okay, so now atoms are neutral. Positives have to equal negatives. So how many positives do we have? We have 3, which means we have to have how many negatives? That's right, 3. So we're going to draw 3 negatives on the outside of this atom. And kapow, our atom is done, right? 3 positives, 3 negatives, 4 neutrals, right? Yeah, well, kind of. So here's the last thing. Now that we have the numbers of the particles figured out, we got to talk about where electrons go. This periodic table thing has so many layers of amazing knowledge stuff on it. The guy that invented it had no idea how much was on it until more and more scientists figured it out. Okay, so the rows of the periodic table tells us where the electrons go. If it's in row 1, first row, it's going to have 1 ring for the electrons, or orbital as they're called. If it's in the second row, there's going to be 2 rings that we're going to draw. If it's in the third row, 3, fourth row, 4, 5, 6. Now 6, see how it goes all the way across there? And then 7, there's a little arrow there that goes all the way across. So it kind of looks like there's 9. There's only 7 rows. I'm going to show you that in the periodic table video next. So don't fret. Okay, 7 rows, maximum of 7 rings. But we always need to fill the first ring before adding another one. And then we fill the second before adding a third. And then we fill the third before adding the fourth. So let's look at how that works out. Okay, so before we check to see if our lithium is right, let me tell you about carbon. Carbon here is C for carbon. Atomic number of 6, atomic mass of 12. And I'm not going to write the carbon just, for the sake of time. So we got 6 positive protons because that's its identity, right? 6 protons. If I have 6 protons and I need to have 12 total in the center, then I need to add 6 more neutrons to separate those protons out. So now I got 6 protons, 6 neutrons, nucleus equals 12. Good to go. Okay. I also need 6 electrons, but let's look at where they go. It's in the second row. So the first row has 2 boxes, which means I put 2 electrons in the first row. There's always 2 electrons in the first ring. Then it's in the second row, so I need to draw a second ring. Now, I have 1, 2, 3, 4, and it's the 4th box over in the second row. So there's 4 electrons on the second ring. That also tells us where the atom is on the periodic table. Okay, so if it's the 6th box over in the 4th ring, then it's going to have all the other ones full and then 6 over. So now, is our atom built correctly here of lithium? Let us check the periodic table. So we put our little table up here. Kabam! We can see that lithium is not in the first row. It's in the second row, which means what's wrong with our diagram? That's right. Our diagram needs 2 rings. So we have the correct number of electrons. We just don't have them in the right place. So I need to draw 1 ring, 2 rings, and then I will put 2 electrons in the first ring because there's 2 boxes in the first row. And then 1 electron in the second ring because lithium is the first box in the second row. So now I still have 3 electrons, but I have them in the correct place, and my lithium is drawn correctly. So here is our steps to build an atom. Step 1, the atom with the atomic number is the number of protons. That is 5 atomic number, 5 protons, always, that's its identity. Step 2, we need to add the neutrons. And we already have our protons in the nucleus, so we need to add neutrons until we reach the atomic mass, because that's how many big fatties are sitting on the couch. Now, step 3, we need to draw the number of rings of the row that the atom is in. And then step 4, we need to add our electrons. We're going to fill the rings. So row 1 has 2 things, so we're going to put 2 electrons in there. Row 2 has 8 boxes, so we're going to fill 8. Row 3 has 8 boxes, and you're going to fill all of them until you get to your final ring. And then put as many boxes over as it exists in that final ring, okay? Always going to fill the first ring before we start a second ring. So before I set you on your way, let's look at a few examples so we make sure this really sinks in. So here is an atom. Who is it? I don't know. Don't worry about the number 4. It's from a different thing in class. So the first thing we can do is count protons. There are 8 protons. And hey, there's an atomic number 8. We can also count everything in the nucleus. And there are 16 things in the nucleus, which is the same thing as 8 because that's our atomic number. So that's our oxygen, and that makes sense with our numbers. But check this out. There's 2 rings. So boom, it's in row number 2. There's 2 in the first, and 1, 2, 3, 4, 5, 6 in the second. So oxygen is the 6th box over in the second row. There's 8 protons, our atomic number, 16 things in the nucleus, our atomic mass. But in order to find these things even more easily, there's 2 rows, and in the second row, there are 6 electrons. And on the periodic table, in the second row, it's the 6th box over. So that is our easy way to find our good friend oxygen. Okay, we're going to look at a couple more examples here. So let me get this all erased. Okay, very good. So now let's look at our friend here. Wow, he's getting a little bit bigger. So now we could definitely count protons if we want to, but let's start with those rings. We know it's going to be in the 3rd row because it has 3 rings. And then in this 3rd ring, there are 2 electrons in the 3rd ring. So it's going to be our little friend magnesium because it's the 2nd box in the 3rd row. Okay? So let's check and see if everything else makes sense. So we got 12, 24, magnesium, which means that if we count, there should be 12 protons, and hey, there totally are. There should also be 24 total things in the nucleus to give us our mass, and that's totally true too. But that ring electron counting thing is definitely a fast way to go as the atoms get bigger. So let's rock a third example here, an even larger one. Now you can totally count that nucleus if you want to, but I'm going to go with rings. So 4 rings means 4 rows. And 1, 2, 3, 4 is going to be the 4th box over in the 4th row. So 22 Ti titanium and 48 is what that box says. It is the 4th, well, there are 4 electrons in the 4th ring, but it is also the 4th box in the 4th row. So that's an easy way to find these bigger elements. There are 2 in the first ring, because we filled that up first. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second ring. 1, 2, 3, 4, 5, 6, 7, 8 in the third row. 1, 2, 3, 4, 5, 6, 7, 8 electrons in the third ring. And then 4 in the 4th row. So all of the previous rings are filled with the same number of electrons in the boxes that are in the rows of the periodic table. So 2, 8, 8 is kind of our rule in that first one. And that gets important as far as like bonding and all of that stuff goes when we get there shortly. There's 22 protons. There are 48 total big guys, protons and neutrons in the nuclear couch, and our electrons are all put in the right place. So lots of tricks to finding the proper thing with an atom and figuring out which one it is if we're identifying. As far as building it, now we've gone through all the rules. If you're still not sure, you can go back through the video and re-watch, and there's also great internet sites too that you can check out.